My name is Mitun Zavery. I am obviously the Director of Solution Engineering here at Sonoside, but I started off as a Java developer. I went through pretty much all of the different aspects of the software development lifecycle, all the way to testing, which was obviously on the other side of the fence when you look at it from a developer's perspective, when I was pinpointing problems in code, all the way into educating developers on using the correct SCM systems, how to obviously check code in, how to migrate from Subversion to Git. So spent a lot of time in the industry. It's been let's say a whirlwind 20 years that I've been here, so it's really fantastic to kind of be here and speak to you all here at the Java user group Istanbul. So hopefully you find a little bit of what I'm talking about interesting and useful for in your day-to-day sort of work and activities that you kind of get on with. So let's get started, I guess, right? So since 2000, when really kind of the uptake of digital transformation kind of started, most of the leaders in the industry have really been under a lot of pressure to change and innovate. And there's been obviously a lot of disruption, right? From the fall of Blockbuster to the rise of Netflix and various other examples of that, right? But 52% of the Fortune 500 pretty much have either diminished in size or have disappeared off the face of the earth, right? And this has really been driven by obviously things like the digital transformation and things like services that where there are no assets, so Airbnb, for example, the transportation industry of e-tickets. This has really revolutionized and changed obviously how things work. And as a Java community, we really have progressed that, right? Creating very innovative apps, mobile web apps, cross-platform applications as well. And that really is driven by kind of this hyper-competitive market, right? It forces organizations to digitally transform. And so that is the only way really for your enterprises, your organizations that you work for to really, I would say, stay relevant in today's market, right? And as developers, as a Java user group, revenue might not be the biggest interest to you, right? It might be creativity, right? It might be the creation of new assets, new capabilities within your forum. So it really does, matter that you stay competitive and you remain sharp and your swords remain sharp, to kind of push that organization forward. So actually, I've talked a little bit about this and covered a little bit around this, but the way software is built, obviously in the industry today, has really changed, right? There's kind of been a change in paradigm, I would say. And it's changed because of well, what I believe anyway, specifically, is this gentleman over here, Edward Deming. And he had a very, very famous quote, right? Cease the reliance on mass inspection to achieve quality, right? And one of the parts of that quote is that you build better or building better quality in product in the first place, right? So that means you've got to think about what you're using, what you're building, and ensure that you are building your applications or your code in the first way. This statement was actually used, obviously, for the lean adoption within the car manufacturing industry, right? So the likes of Ford and Toyota. In fact, Edward Deming was pivotal in the rise, right? And pretty much the leading factor why Toyota became such a successful automotive company in the first place, okay? And then Ford onto that as well. So his principles that he taught and educated the masses on really ensured that most of the organizations that follow that lean principle really were successful. And it was about building quality into the product in the first place, right? We needed to make sure that everything as an organization you were doing was around where are you getting these parts from, okay? Use only the highest quality parts inside of your vehicle, right? Or your application in today's world, okay? And build that in from the start to kind of make sure that you are thinking about the quality of the product, you know, how it's going to be when you finish. And finally, one of the things around this was creating something called a bill of materials. And a bill of materials really was a way of saying, this is everything that is actually inside of my car / application in today's world, right? And this is what I'm using. And this is what, if someone was to look at in 10 years time, this is the thing that I need to validate is still good and is of good quality. And so that's where the paradigm shift has come. And now we're talking about software supply chains, right? Very similar to automotive supply chains where they're sourcing bolts and parts and engine car parts. Well, this is exactly the same, right? For the automotive, for the application industry, right? For the software development industry, it's effectively the software supply chain. But, you know, what makes up a software supply chain, right? And really, you can see here 4 components that really make up the software supply chain, right? Your open source components that you are gathering from Maven Central, hopefully. You know, you might be gathering it from other sources like JCenter, but obviously JCenter is going to be sunset at some point. Your source code, right? Your innovative work, the work that you're putting effort into to make sure is really unique to that application or that industry to kind of make your organization competitive. The containers that you are pushing those applications into. So your open source and your source code are being built on base containers. So now you're deploying these applications in the form of containers. Your infrastructure as code. So how are you building the configuration of the infrastructure that these containers are then going to be sitting on? So really, there are 4 parts to the software supply chain. And this is just simply something that they really don't teach you sort of in school, right? When you focus on developing an application, the biggest part that is part of your application in the first place doesn't come from yourself. It comes externally from other sources, right? It's from the open source components. And as a Java user group, you're contributing to some of these open source components that are out there, right? You want to make sure that the quality of these components are fantastic, they're good, so that when you use them in your projects inside of your organization, they still are good, right? And so there is a huge part of the software supply chain that is really unseen. And if we just take the open source components just for the time being, 90% of any application that you as developers will develop, 90% of it is actually made up of open source components, right? Whether you believe that or not, or whether you do actually start projects from scratch with Java, right? That's a little bit different. But every single day, 21,000 plus versions of open source components are released per day. So let's just think about the scale, you know, just for a moment as to how large that is. That is a large number of components every single day. Now, just take into consideration the amount of change that that brings inside of the open source community, right? If 90% of all applications that are developed by organizations and developers are open source components, and every single day they are changing or new versions of them are changing, think about the huge impact that has to the software supply chain. Think about how that impacts the organization that is developing the application in the first place to make sure that they stay secure, they stay compliant, their application is of good quality. It becomes extremely difficult. And just to kind of put that into perspective, what does that mean to you as developers? Well, last year alone, and during the kind of, you know, pandemic that we've had, there was estimated to be 345 billion Java components downloaded in that time. And you'll see actually this bit of a hockey stick over here. This is not slowing down. In fact, this is getting bigger. And now that we're talking about containers, this is getting even bigger. There are about to be 90 billion images downloaded in a year by developers, by organizations. So all these Docker containers and images that are being downloaded contain open source elements to them. And if 345 billion components are downloaded in that year, then there's a huge number of open source components that go into those containers and images that you are publishing out and running. Now, source code, of course, the only way to make your applications innovative is by adding your unique IP to that. And that is the source code that you are developing. But the only way you can stay relevant in the market and continue to develop faster is obviously by increasing the speed of your deployments. So if you're slowed down by continuous policies and checks to kind of make sure that, well, my application is still not vulnerable and my application is safe to go into production, that's a frustration for you between development and security. But it's a valid frustration for the organization and the security people because, as Ashley said, there are probably 100 developers to one security person. And right in the middle of those individuals are 10 operations people going, whoa, slow down. We need to slow down the deployment of these applications because I need to validate what's inside of them. And as developers, our goal really is to increase our velocity. Because the faster we move, the better it is for our backlog because our backlog is shorter. And it means you're obviously developing better code over time, and you can start to work on some of those really interesting and innovative kind of capabilities that you want to pull out. I talked about the third element of the software supply chain as well, right? There was a statement recently and a research done that stated that by 2022, more than 75% of organizations will be using containers within their organizations, whether it's running in a container environment or deploying containers to their customers. This is going to happen, right? And this was sourced by sort of Gartner in 2021, right? So they've seen a huge velocity, right, of adoption for containerized applications. Everyone is moving to the cloud. Everyone wants to adopt the use of containers because it's manageable. It's easier to deploy applications. It's easier to pull applications, upgrade applications, right? And so if you think about the use of containers increasing, right? I threw out the figure 90 billion potential containers being downloaded in a single year. That's a lot of open source that is going into those containers. And that is a lot of source code going into those containers. And then the final part of your software supply chain really is the infrastructure that you are running those containers on. Now, what organizations are also pushing these days is this idea of the Devops tool chains. And of course, developers have an influence into those tool chains, right? And really can be sort of the influencers in that. And as developers, you have now been also given the authority to develop, infrastructure as code, right? Changing that, ensuring that is run appropriately, building the configuration as part of that, making sure that you're gathering the right pieces and elements for your application to run successfully, okay? And again, right, this is a source from Gartner. By 2023, 60% of organizations are going to be using infrastructure as code because what they want to do is they want to automate the deployment of their applications. They do not want to sit behind manual sort of checks and validation points to say, yes, my infrastructure is correct. Yes, my infrastructure is secure. Yes, we can now deploy that application out. Yes, version 1.2 or 2.1, whatever it is, right? They want to improve the efficiency. So if you haven't already gathered by now, the whole concept, right, of DevOps really is what Edward Deming talked about, right? It's ensuring your supply chain is secure using the best quality parts so that you can increase that deployment efficiency. And you can improve that deployment efficiency by 25% if you're using infrastructure as code, And if everyone is adopting containers and everyone is building quality into it right from the beginning, then really you've got a good chance of really staying relevant in the market, right? If you are an independent developer or if you are an organization. So that's all great and fantastic. The problem is, and this is obviously some statistics from the DevSecOps survey in 2020 and the 2020 State of Software Supply Chain, you can see that open source doesn't really age that well, right? Open source is a little bit like milk, okay? It ages badly. Wine gets pretty good over time, but milk doesn't age very well. And in fact, in the time, obviously, since the 2020 DevSecOps survey, we've seen a huge growth in these numbers that you're seeing here on screen. And one of the things that we're seeing a lot of actually is there are open source components, especially in the Java ecosystem, right, that are becoming vulnerable, or at least 1 in 10 of them have vulnerabilities in the open source community. And unfortunately, most organizations typically don't tend to have some sort of governance policies in place, right? And we're talking about here about, you know, breaking silos, right? Talking about making sure that security policies don't slow you down. That's great if you don't have any policies because you'll move very, very fast, right? But the problem here is if you don't have any of these checks in the first place, then you are prone to a breach, right? And these breaches can become quite costly, right? And an organization, its effect of brand, its effect of your position in the market. But as a developer, and if you are working on that project and it is the one that becomes vulnerable, well, there's a risk of your work, credibility of you as a developer. What are you doing? Why did you not focus on that? Ultimately, the responsibility flows down to the developer, right? And it's up to the developers to focus and really think about what they are using. Now, kind of put it into perspective, this software supply chain attacks, or the terminology of software supply chain, hasn't been used for a very long time, right? We've been advocating the use of, you know, software supply chain for many, many years, but it's not really something that has kind of really grasped people's attention because it was a terminology used by the automotive industry. It is now very relevant in today's world because these software supply chain attacks, with hindsight, we're able to see back that these things have been happening before 2012, right? So the pre-dawn of when these things used to start, you could see Heartbleed was really just one of the first examples of a software supply chain attack. And no one really thought that Heartbleed was a software supply chain attack, right? Everyone just thought this is a security breach, right? 800,000 TLS-enabled websites were left vulnerable. That's a large number if you think about it. But with that being left vulnerable, imagine the amount of data loss that occurred with Heartbleed. What did we lose? What data came out? Whose credit card information was unsecure at that time? But I think one of the biggest ones I think that made the headlines and I think really changed the way people thought about security was obviously, you know, about 4 years ago in 2007 when Equifax and various, I mean, Equifax has become kind of the poster child for this, right? But Equifax have really revolutionized the way that they do security within their industry now. In fact, they're probably one of the trendsetters of how to do it right now, right? Because of mistake. But there were other examples, Japan Post, India Post, right? Okinawa Power Plant, right? But they were big impacts, right? And they were breached within 3 days of actually knowing or the component being used, right? 3 days. It took a potential attacker to penetrate an attack vector and infiltrate an organization, whether to exfiltrate information, to cause damage. We obviously know what happened, obviously, with Equifax, where a lot of their senior executives were permanently put on holiday. But that's continued. And let's fast forward, obviously to today, right? Around. So 2 months ago, there was the dependency confusion, copycat attacks. Now, this didn't really affect the Java ecosystem because guess what? Maven Central was really built to make sure that these types of attacks were never a problem in the first place, right? We make sure that you, if you are publishing to Maven Central, validate who you are. Do you actually own that domain? And are you actually a person allowed to publish that component with that namespace to that component? A lot of other ecosystems simply do not do this. They are prone to it. And so 2 months ago, there was a big push around dependency confusion, right? Which affected very much the NPM.js ecosystems, Python, all of the ecosystems that were a little bit sort of more free with publishing, right? The perceived ease of use, right, of publishing to those ecosystems. Now, that's great because obviously, that really didn't hurt anyone in particular. However, if we remember and we go back to the third part of the software supply chain, it's containers. It is containers that you use. And only recently, in fact, over the last week or so, there's been a new software supply chain attack called CodeCoff. And CodeCoff has a bash uploader script within it, and most developers consume CodeCoff via a container, okay? Now, obviously, the attackers altered that bash uploader script inside of that container, and developers continue to pull the latest image from Docker Hub. What did that leave? That left basically an open door into the container that allowed the container to go and exfiltrate details of the developers, right? What were their keys? How were they running the code? What were they testing? Now, developers have elevated permissions within the organizations anyway, right? They are effectively the people that have the ability to execute code, push code, make changes. So you have a huge responsibility within your organization, or the use of these tools within your organizations. And that container very much opened a door into the organization. And if you think that's not relevant because obviously, no public vulnerability, has been seen. Last week itself, a Japanese retail company published that they were breached by CodeCoff. They lost 17,000 people's data, including credit card information, addresses, names, etc. It is the largest breach to date, obviously for CodeCoff, but one of the biggest breaches to date in terms of a software supply chain, especially around a developer tool. CodeCoff is a developer tool. It is not used by anyone other than developers. So it's really important for us to really consider why the supply chain is important for us as developers and why we should be focusing on really thinking about taking care of this. So let's talk about the challenge, right? There have been many publications around the challenges, right? But I wanted to bring the focus really, to obviously Turkey, right? We're in Java User Group Istanbul. Let's bring this home and really talk about what does this mean to you, right? And in fact, a really interesting one. There was a new regulation within Turkey, right, that forced information systems inside of Turkey, obviously, to pay attention to this. And in short, this was kind of called a Bddk regulation for banking, right? But effectively, this was one of the new publications that was put out there. And it enforced organizations, especially in the banking industry, to rethink about what they were using in terms of software quality. But it allowed, obviously, the regulators, right, to go and really target organizations that were not complying. And well, if you weren't complying, something revolutionary really was happening inside of this inside of Turkey anyway, they were going after the organizations and were fining those organizations. So actually during lockdown, so during the pandemic, Turkey's banking watchdog basically made a cool $48 million of fines, obviously for these organizations that were failing to comply. And of course, this is fine, right? Because what they are ensuring and what they are trying to make sure is happening is that they are using the best components. They are following kind of a software supply chain best practice. And if you don't know what these are and you're not sure what this really means for you, let's take a look at it actually. So, why do these Bddk regulations matter to me, right? Well, Article 22, security built into the software development lifecycle, okay? It requires you writing policies to ensure that you have thought and considered the components you're using or the software you're developing complies with best practices. And the article demands that it is built into the security, right, into the software development lifecycle, in your entire software development lifecycle. So you want to minimize risk and increase quality. Article 15, security config management, right? You must implement whitelists for applications and libraries, right? So if you don't know what's a good library to use, then you should find out, right? And actually, the concept of a white and a blacklist is actually pretty old, right? In fact, it's probably something that is becoming outdated by the use of policies, right? Because whitelists and blacklists are pretty rigid and require you to obviously update the white and blacklist quite often, right? But you need to be able to know exactly where these things are being used. So understand based on your config where a component is being used in your application. Article 6, vulnerability and patch management. What do you do if there's a new vulnerability and you have to patch the environment? Okay, understand the process. Understand that you follow the guidelines. Who are the people that are going to have to make that change or patch the application if a new vulnerability is published? It's the developer. The developer needs to understand where this information is coming from, where it's actually being called within my application, and how do I prevent it from actually being used. And then finally, change management, typical security change management functionalities inside of that. But what this has led most organizations around the globe to do, and if you didn't think that this is what the Bddk regulation was, well, in fact, this is what it is. The Bddk regulation is saying organizations will require response. Also, the president of Turkey is super happy about that, right? And approves. But hang on a second. What is an SBOM, right? No idea. Well, let's figure it out. An SBOM is effectively a software bill of materials. It is a list of all your components that exist inside of your application. And based on sort of Gartner technology insights, software composition analysis, or a software composition analysis, which generates a software bill of material, basically it'll be a non-negotiable requirement by 2024. So by 2024, you as developers, as organizations, need to be comfortable with generating a software bill of material. And this will mean that you have the ability, in the concept of, Edward Deming, understand what components you're using, use the best components inside of your code, understand where they are being used. It will be a requirement for you as developers, as Java user group, to understand where these things are coming from. And as developers, typically we just use the best components for the job and it achieves what we need to. But it's now a responsibility for us to make sure that we get that. So, great. So all supply chains should follow the same quality principles. And that is really what the software supply chain is trying to advocate, right? Using the same quality principles. And so that means, like I stated, right, using fewer parts, use them from known suppliers that are good, right? Understand that open source project that either you're contributing to or you are consuming from actually has good components and good quality code that you are using. Only use the highest quality parts, right? You wouldn't put rubbish tires on your car if you were driving in the rain, right? You would simply use the best quality tires that you could. Building in from the start. I think this is the hardest one for most organizations and developers to follow. It's what do I do? How do I do that? And so you have to build that in from the start. And actually, I'm going to go into a couple of things here that really kind of take you down that journey, and definitely things that they just don't teach you, right, in education. And create a bill of materials. Final output. You have to ensure you're creating a bill of materials. It is your audit checkpoint. It is where you find what is that application containing and what was pushed out into production. And I did promise you, right? I am going to help you to try and figure this out. And we do provide a whole host of tools. And actually, there are a whole host of tools out there in the market, but there are so many that it really becomes difficult to really understand where do I look for these things. But it is really up to the developer to kind of leverage these tools, use them, make sure that you are using them to go figure out what those dependencies are. So let's start looking at some of these. So one of the things you do as developers is you typically go and try and find the best component to use, right? This might be that you just use Stack Overflow, or you use jQuery, JCenter, or whatever it is. But actually, there is a Chrome plugin. You can download this. You can see the URL. It's down there. It's part of the Sonosite Nexus community as well. So it's an open source project. You can contribute to that as well. And what does that allow you to do? It allows you to go and see what vulnerabilities exist. So let's take that for a bit of a spin, right? So let's go and have a look at that particular component. So here you can see the component and the version, and you can see that we're telling you there is a problem, okay? What does that mean though? So if I take a look at this and I have a look and see what the issues are, I come back and I straight away tell the developer that, hey, this particular component and this particular version, right, have 16 security issues related to it. Now, as a developer, you'll be sitting there thinking, well, what does that mean to me, right? How do I fix that, right? And you could go and look at every single CVE that exists for that component. And actually, for Jackson Databind, really, obviously, it's an XML parser. You could really go and take a look and see and try and figure that out. And you could use the information for the CVEs that is referenced actually inside of here to go and take a look at all of that. But that's actually a lot of work, right? You would have to go and look for every single CVE. You would go and have to understand exactly what the issues were and actually, what you were seeing and understand that. But that takes time, that consumes you. So that doesn't really encourage the flow of adoption, right? And the efficiency gains. So what do? We provide you a remediation or a component information panel, right? A bit like a dependency graph, if you want to call it. But effectively, this gives you the ability to say, based on the policies that my organization has within my group, I should be using these components, or this component specifically, this version of that component, that may not have any vulnerability associated to it, based on the policies in my organization. So now you're not being blocked. You're not just downloading that version, that specific version of Jackson Databind. You're not using it and consuming it. And then when you get to a build pipeline, it goes, you are not allowed to use it. You're actually being informed as a developer to say, go take a look. Have a look at this version. This one complies with policies within my organization. And it also gives you information like your licenses that are used. And that is a really, really important part of using the components inside of your application. And so that's one way. That's even before you download the component, you can use this data to say, well, does my organization agree with the use of this component? But did you know that actually there is a free security data resource available? And guess what? It is the Oss Index. The Oss Index allows you, or is a way of cataloging open source component vulnerabilities inside of the ecosystem. So you could go to that URL, so Oss Index, and go take a look at that. And let's go take a look at that, because actually, you know, that is really, really useful as a developer. And so in here, I have the ability to search for components. Now, if I just take, you know, that one as a Struts core as an example, right? And I see, are there any vulnerabilities? All right, look, well, there's a vulnerability in the Maven ecosystem for Struts core. What is it? Well, there are 43 critical vulnerabilities, 32 severe ones, and 1 moderate issue. What do I do? Well, I've got a couple of ways of doing that. I can use my Maven plugin, obviously, to scan that, and we'll go into that in a little bit. I'll show you an example of that. But there's also a Gradle plugin. So if you're using Gradle to build your Java projects, there's a Gradle plugin to go and do that. But if you don't build the application anymore and you just want to understand what the risk is, you can use the vulnerability scanner. It just simply gives you a quick check to say, hey, is this thing that I am using valid and can I use it? And in fact, you're seeing that there are vulnerabilities, but you're not seeing any data. So what I do, go and log in, create yourself a free account. Doesn't cost you anything. You log in and you can go back to the search. And this time it's going to give you the vulnerabilities. You can go and take a look at these. I can see all of the versions. So I can see 1.3.10, obviously it's a very old version probably, but these are the vulnerabilities that affect it. This gives you confidence in using the components. And if you really wanted to go and really take a look and see, you know, what the issues are, let's look at a recent vulnerability. That information's there. How complex is the attack? Is there any user interaction? What are the references? What's the CWE, if there is one that's recorded for me? What's the vector of attack? But what are the affected versions? So you know that everything up to 2.3.24.1 is affected. So really, there's no point me looking at version 1.3.1 because I know everything up to 2.3.24.1 is vulnerable. So use it. It's a fantastic resource. So now you have the ability to look for the components, but you're going to start developing and you're going to want to start using your source code, either public projects, right? So if you do develop open source projects, you're going to want to validate the source code that you've built into that. So why not use DepShield, right? Again, completely free to use. And you have the ability to actually go and take a look at that. So let's take a look at one of my examples of my projects, right? So I've just got a WebGoat project inside of here. Very, very simple, purposely vulnerable project. And you have the ability to obviously see the security issues that are inside of there. But I have these integrations set up through my GitHub project, right? And these are all available on the GitHub marketplace as well. So you could simply go into the marketplace and really just download and configure your dependency shield, right, for your particular project. So here I can log in, see what the configuration is, and I can enable this on all of my repositories that I have. So all of my repositories are actually being protected by DepShield if I want to use it. And I installed this 3 years ago just to really keep it, you know, making sure that everything is working fine, making sure that any pull requests that come in, obviously I can see if DepShield has a problem with any of those, and there are any CVEs associated with that. And you get that all inside of your source code as pull requests or issues that exist inside of that. And it will take you back to obviously the data in Oss Index, right, to kind of see what is vulnerable and what you should be using. So that's a great way of actually doing, you know, ensuring that your projects are secure. But guess what? You are gonna be using things like SonarQube to link your projects, check for code quality. And this has become extremely critical these days. And yes, maybe SonarQube was the only way for you to think about that. But Muslib has been in the market for a while and it's actually available on the marketplace as well. But that is another way of and ensuring your code quality inside of your application. Go have a look at that on the marketplace, right? It supports various different languages that allow you to fix the problems inside of your source code and points you to the piece of source code in your project that allows you. Let's have a quick look at that. So here are all my projects that I have. And again, this is completely free to use on the public open source projects as well. So let's take just an example here. So let's go into my Juice Shop project. Now, if anyone doesn't know what Juice Shop actually is a purposefully vulnerable JavaScript project. Yes, we're here in a Java user conference group, but it's kind of the same, right? So if we have a look at this, you can see straight away that there are unnecessary, we've linked to the actual project as well, and you can actually see that inside of my source code, there are a few problems, right? So in this particular one, we're being pointed to an extra semi for no reason, right? In the code quality. So we can go, and that generates the pull request inside of your source code so that you can go and fix those particular projects. If I go back to here and I kind of see what other issues there are, let's focus on the open source projects themselves. So if I say I'm only going to focus on my open source projects and I'm only going to focus on the critical ones because these are what I need to fix very, very quickly, I can go all the way down to where that package is. So let's look at this package. I'm using an NPM package. It's called WebSocket Extension 0.13. There are some open source vulnerabilities there. Let's have a look at those. Okay, those are now vulnerabilities that exist inside of my open source package. But let's have a look where that thing is. And you can see we identify exactly in the source code in your manifest file where you're calling that. Now, you may not know that that is something that you are actually calling inside of your code, but you should go take a look at that. Now, you're going to be developing. So the first thing you want to do is develop securely. So why not use a plugin within your IDE? And so I have a Java project here. I have my VS Code extension installed on there. I'll show you the link again. Again, this is completely free to download, but you can see the vulnerabilities inside of your projects for my Java project that I have over here. It gives me the information about why is it vulnerable? What is the package URL? So what's the specific vulnerability that exists? What are the policies that my organization is saying that are broken because this particular thing is being used? Why? And what are the security vulnerabilities? And what is the information and the details around those particular security vulnerabilities that you have over here? So now you're empowered to go and fix those particular problems inside of your code. So go have a look at that, take that, install that. But if you are not one to sort of use, an IDE and you want to stay within your build tool, we have Maven plugins and Gradle plugins as well. You have the ability to validate your Java code via the build tools themselves. And here I have an example, actually, if I just clear the screen just to kind of give you an idea. Here's my WebGoat legacy project. I can run the scan of that project directly in my build tool as well. So you have the ability to actually build the code, and as you're building locally inside of your environment, you're presented with a list of issues that are there. This, I agree, is a little bit difficult to obviously consume and look, but you've got the unique URL to show you exactly what the issue is and what vulnerability is in there. Now, you'll be able to see actually that if we go to the top, there are no excluded lists. So if you have a list of vulnerabilities that you want to exclude, as part of this, you can exclude those coordinates and those vulnerabilities yourself if you really want to. But again, we're moving away from that concept of a whitelist and a blacklist. And so go take a look at those. They're all part of your build tools. These are the URLs for you to be able to go do that. Now you're probably thinking, oh great, but I develop a bit in JavaScript. I maybe got some Python inside of there as well. All of these are fine. There are native scanning tools that give you the ability to do that. One of the most interesting ones is Ahab. Ahab allows you to scan a Docker image, right? If you have the Docker image and its dependencies, which Ahab will gather for you, you are able to go and validate what vulnerabilities actually exist inside of that. And so these are all available actually inside of the Nexus community forum. So you can go here to the Nexus community forum. You can see Sherlock Trunks, which is the Gradle plugin, is there. There are some examples in there for you to be able to use. So go take a look at that so that you can use that. So these are great. But just to bring it back into focus and just in closing, you are all probably using a component that has probably thanklessly been maintained by someone in Nebraska since 2003. And all modern digital infrastructure is really built on these open source components. And this meme is great because imagine just taking that block away, you end up with obviously a huge problem and a lot of bricks falling over. But in Sonatype, we advocate obviously securing the pipeline and securing the pipeline across all of the different elements of that pipeline, right, in your software development lifecycle, from source control all the way up to the repository and the release. And that's really why we call ourselves kind of a developer-friendly, full spectrum software supply chain management solution, right? It allows you to kind of look at the 4 aspects of a software supply chain. Now, I usually have a list of takeaways to kind of give you, but really the takeaway for me and to you in the Java user group is really try to think about some of those lean principles. Think about the software supply chain and implementing those 4 points inside of there, where you're sourcing your components from, using the best quality components, building a software bill of materials. It is really up to you as developers to do that. You have the power to do that, and you have the tools available to you in your IDEs, in the marketplaces to do that as well. So I'm going to leave you with an inspirational quote, right? The arc of software innovation is long, but it bends towards empowered developers. That was a quote by Brian Fox. And if you don't know who Brian Fox is actually one of the co-founders of Maven Central, is obviously a contributor to that as well. And obviously some type of advocate are maintainers of that as well, for you as developers, so that you can gather your components and build software quicker and faster. But we really believe in empowering you as developers and making sure that you're able to work quickly. So to that end, we're running obviously an Elevate conference. Please join, register if you can. But thank you to the Java user group for having me here today. Hopefully you're still all awake and you found this really useful. The slides will be available. There's a lot of tools for you to use, but really, advocate using these open source tools. They're not teaching you this in school, in university. These are just simply enterprise approaches to ensuring the software you're developing inside of your